In this video, we're going to talk about solubility of substances. So, we can have the solubility of a substance either in gram per dm cube or in mole per dm cube. So, what do we mean? Solubility in gram per dm cube is the mass of the substance, and we know that the mass of a substance is in gram in 1 dm cube of a solution. That is the grams of a substance in 1 dm cube, that's decimeter cube, or 1 liter. 1 dm cube is equivalent to 1 liter of a solution. And then the formula for finding the solubility in gram per dm cube is mass in gram divided by volume in dm cube. Which means that, for instance, if we have 1 gram of a substance dissolving in 1 dm cube or 1 liter of a solution, then the solubility in gram per dm cube will be 1 gram per dm cube, or we can say 1 gram per liter. So in this video, I'm going to be using dm cube in place of liter, but put it in mind that dm cube is equivalent to liter. dm cube is equivalent to liter. Okay, so now most times when you are dealing with solubility of a substance, maybe you are solving a problem, you will most likely be given the volume in cm cube, but you need to convert the volume in cm cube to dm cube. So how do you do that? To convert volume from cm cube to dm cube, the volume in dm cube will be equal to volume in cm cube divided by 1000, because we know that 1000 cm cube is equal to 1 dm cube. So you have to divide the volume. If you are given in cm cube, you have to divide the volume by 1000 to get the volume in dm cube. Okay, so now what do we mean by solubility in mole per dm cube? Solubility in mole per dm cube, it's the number of moles of a substance in 1 dm cube of a solution. Notice that here we use mole for solubility in mole per dm cube. Here we use mass for solubility in gram per dm cube. So the solubility in mole per dm cube is the number of moles in 1 dm cube of a solution, and so the unit is mole per dm cube, because if we have 1 mole, okay, we can say that the formula for finding solubility in mole per dm cube is equal to mole, which the unit is mole, over volume in dm cube, the mole of the substance divided by volume in dm cube. You can compare this with this mass of the substance divided by volume in dm cube for solubility in gram per dm cube. But for solubility in mole per dm cube, we have mole divided by volume in dm cube. So now, what is this equation here? This equation shows the relationship between solubility in gram per dm cube and solubility in mole per dm cube. So the relationship between the two of them is that solubility in mole per dm cube is equal to solubility in gram per dm cube divided by molar mass of the substance in gram per mole. So if you calculate the solubility of a substance in gram per dm cube from the solubility in gram per dm cube, you can determine the solubility in mole per dm cube by dividing by the molar mass of the substance. Yeah, I think that's clear. So let's solve this question. 15.3 grams of a sample of potassium trioxochlorate 5 was required to make a saturated solution with 50 cm cube of water at 25 degrees Celsius. What is the solubility of the salt at 25 degrees Celsius? What is the solubility of the salt at 25 degrees Celsius? Now, let's write out the given parameters, the known. Here, we were given 15.3 grams of a sample of potassium trioxochlorate 5. So we have the mass in gram is equal to 15.3 grams. So it was used to make a saturated solution with 50 cm cube of water. So we have the volume of the solution which is 50 cm cube. What is the solubility of the salt? But actually, if you look at the options here, we are looking for the solubility in mole per dm cube, not in gram per dm cube. But before we can find the solubility in mole per dm cube, we need to first of all find the solubility in gram per dm cube. Then after we find the solubility in gram per dm cube, we can then use this formula to find the solubility in mole per dm cube. So now, let's find the solubility in gram per dm cube. First of all, we need to convert this volume from cm cube to dm cube. How do we do that? Remember that we need to divide it by 1000. So that will be 50 cm cube divided by 1000. Now 50 divided by 1000, that is going to give us 0.05 dm cube. So we've converted the volume to dm cube. So now we can find the solubility in gram per dm cube, which is equal to mass in gram divided by volume in dm cube. So what is the mass in gram? 15.3 gram divided by 0.05 dm cube. So let's do that. 15.3 divided by 0.05, and that is 306, is equal to 306 gram per dm cube. So now we know that the solubility in gram per dm cube is 306 gram per dm cube, but the question asks us to look for solubility in mole per dm cube, and we know that it's equal to solubility in gram per dm cube divided by the molar mass in gram per mole. Molar mass in gram per mole. So how do we calculate the molar mass? Because we know the solubility in gram per dm cube. How do we calculate the molar mass? To calculate the molar mass of KClO3, we are going to add the atomic masses of each of the atom. So for potassium we have 39, chlorine is 35.5, oxygen is 16. So we have 39 plus 35.5 plus oxygen is 16, but we have 3 atoms of oxygen. That will be 16 times 3. So that will give us, let's do that, 39 plus 35.5 plus 16 times 3, and that is 122.5 grams per mole. So we can go back to this formula to find the solubility in mole per dm cube. So we can now say solubility in mole per dm cube is equal to the solubility in gram per dm cube, which is 306 gram per dm cube. 306 gram per dm cube divided by the molar mass, which is 122.4 grams per mole. So let's do that. 306 divided by 122.5, and that will give us 2.498 mole per dm cube, because remember that we are looking for the solubility in mole per dm cube. 2.498 mole per dm cube. Let's look for the correct option. 2.498 is approximately 2.5, because if we approximate 2.498 to one decimal place, to be approximately 2.5 mole per dm cube to one decimal place. So which means that the correct answer here is option A, 2.5 mole per dm cube. Thank you for watching. Don't forget to like, share, subscribe, and give a comment. Thank you.